Yes, your scarf bars. All right, we're going to get through this lesson quickly so that y'all can take your quiz, especially the people who missed it yesterday. All right, name the rule that would prove the triangle similar. This is what your quiz is over today. So I'm going to give you a couple of minutes to look at these 3 problems. All right, so Johan says that number 1 is side angle side similarity. Let's look at it. Number 1, we can add arcs because we have vertical angles. Remember, if you're going to add a symbol, you have to have a reason. So our reason for adding that was vertical angles. Then you need to test the sides. To test the sides, you find which sides correspond with each other. If you don't know which sides correspond with each other, then you put small over small, large over large. So the smallest number is 9, the smallest number is 3. 9 is to 3 as, the largest number is 15, the largest number is 5. Small over small, large over large. And you see if it's true. 9 divided by 3 is 3, 15 divided by 5 is 3, so that is a true statement. So these are guilty of being similar by side angle side similarity. Do you have to put the similarity symbol? Yes, you have to put the similarity symbol, the squiggly. All right, number 2. Tahar, did you write your answer? If you So the next one looks like it could either be side, 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 or nothing, right? Because there's no angles given at all. So you can't just say, oh, I've got 3 sides, I've got 3 sides, so it's side, side, side similarity. You do actually have to check the proportions. You actually do. So I'm going to put small over small, medium over medium, and then large over large. And I'm going to see if those equal. Okay? 7 halves, does that equal 14 fourths, which equals 18 fifths? When you divide those in your calculator, do you get that every time? 7 divided by 2, 3.5. 14 divided by 4, 3.5. 18 divided by 5, 3.6. So this is true, and this one is not true. So what's the answer to number 2? Not similar or none. Whatever the directions tell you to say on the quiz, use that. They might say put NS for not similar, put none, put not possible. Okay. Last one, I called on Araceli. What'd you get for number 3? So to answer angle, angle, we would have to have 2 angles. I see 1 angle for sure. Do you agree that 90 equals 90? Check. What other angle do we have? Well, nothing. We don't know those other 2 angles. So it's definitely not angle, angle. What are other choices? Side, side, side. Do we have all 3 sides? No, we don't. Could we find all 3 sides though? Yes, we could, because in right triangles we have this thing called Pythagorean theorem, and you can find the missing sides. The other choice we have is side, angle, side. Look at this one. We've got side, angle, side. But in this one we're missing a side, and then we have angle, and then we have side. Be careful. I gave this one to you on your homework. It's not 9 over 25 equals 12 over 15. 9 does not correspond with 25. 9's a leg and 25 is the hypotenuse. So what I'm going to do is Pythagorean theorem. I'm going to do 25 squared minus 15 squared. Sorry. There we go. 25 squared minus 15 squared. It is a Pythagorean triple. We'll talk about that next unit a lot. And so what is the answer to that? Square root of 400 is 20. So this number that goes here is 20. I would now mark that out because I don't want to accidentally use that one. So now let's see if the sides are proportional. So is this true? 15 is to 12 as 20 is to 9. Are those proportional? So you go to your calculator and you divide them and you see if you get the same thing both times. What do you think? No, those are not proportional. Those do not reduce to the same fraction. So number 3 is none, or not similar, or not possible. Let's check our homework answers. last night's homework was called mid-segments. The major things about a mid-segment is that a mid-segment is parallel to the third side of the triangle. A mid-segment is half the length of the third side of a triangle. So those were two major things we learned. A mid-segment is parallel to the third side of a triangle. Sometimes I call it the base, although it's not technically the base. And it is half the length of the third side. Okay, we are looking at number 7 from the homework. It says that the mid-segment is 2x, that's DE is 2x. BC is x plus 10. So we learned that the mid-segment is half the base. You double the mid-segment to get the base. So 2 times the mid-segment equals the third side. Double the mid-segment to equal the third side. So 4x equals x plus 10. Subtract x. 3x equals 10. Okay, so x is 10 thirds. It wasn't asking for x, it was asking for DE. So we plug it in. DE is 2x, so 2 times 10 thirds. So DE is 20 thirds. 19, we did this one so quickly at the end of class yesterday that you might not have totally understood what I was saying. Exactly one of the values can be determined, find it. So only one of those are mid-segments. I agree that all 3 of those look like they're a mid-segment, but only one of those is actually a mid-segment. We need to figure out which one is actually a mid-segment by finding by finding the midpoints. I cannot scroll. Okay. So, is this point a midpoint? 3 and 4. And it's not a midpoint. This one is 5 and 5. This one is 2 and 2. So you connect the dots. You connect your midpoints. A is the only mid-segment there. A, that's it. So what you do is you look at the third side, the side that you didn't use, and you find the length of the third side, and you divide it by 2, 3.5 or 7 halves. Okay? All right, so this lesson is called Ratio of Area and Volume. Ratio of area and volume. So, if I call my scale factor K, because that's just what we're going to call it, if I call my scale factor K, the ratio of the sides is K. The ratio of the areas is K squared, K to the second power because area is 2D, and the ratio of the volumes is K cubed, K to the third power because volume is 3D. Now, when I say this word dimension, I could be talking about the sides, I could be talking about the perimeters, I could be talking about the height, H-E-I-G-H-T. Anything that is 1D is what I'm saying when I say dimensions, okay? So we've got the scale factor, we've got the scale factor squared when it's area, we've got the scale factor cubed when it's volume. Okay, moving on. So find the ratio of area and volume for the similar water bottles. We've got his and hers water bottles. Okay, so first you have to find the scale factor. You have to find the 1D ratio, the scale factor. Scale factor is second over first. Second over first. So the ratio of the diameters is 4 to 3. We are not going to put the decimal version. We are not going to put the decimal version. All right, so what's the ratio of the areas? Well, the last slide told us take K and square it. Take the scale factor and square it. 4 thirds squared. You just square the numerator and you square the denominator. 4 squared, 3 squared. So there's the ratio of our areas, 16 to 9. Lars, a point is 0D. A point is a location in space. It has no dimension at all. Lars was asking, well, if a line is 1D, then what's a point? 0 dimension. It has no thickness or measure, really. It has no measure. A point is simply a location in space. All right, ratio of the volumes. So you take the scale factor, you take the 1D ratio, and you cube it. Does everyone know how to cube something on your calculator? You use the 4 and then this little caret button and then 3. 4 to the third is 64. 3 to the third is 27. If those were reducible, we would reduce them, but they're not. They're in simplest form. Or you do 4 times 4 times 4. Okay, I guess so. Sounds really inefficient. All right, isn't that a beautiful aquarium? Look at that. That's in Berlin. It's a huge cylindrical, that's a fun word, a huge cylindrical aquarium in Berlin. The volume of that aquarium is 800 cubic meters. 800 cubic meters. Almost the size of my bed. Okay, anyways, someone else wants to copy this aquarium because they think it's beautiful, but they want theirs to be a little bit smaller. They don't really have the budget to make that aquarium. So they're going to produce a similar one. They're going to keep all the dimensions the same, or sorry, the proportions the same. And they're going to use a scale factor of 4/9. We already know it's going to get smaller because 4/9 is less than 1. Find the volume of the new tank. Here's what not to do. Take the volume and multiply it by the scale factor. And that would be wrong. The problem is that volume is 3D and scale factor is 1D. The volume is 3D and the scale factor is 1D. We cannot multiply when our dimensions don't agree. 1D and 3D, they don't get along. They don't agree. They're not in unison. Okay? They're not a unified front. So we need to do something to our scale factor. We need to cube it. Okay? So 4 cubed over 9 cubed. I realize the numbers get large kind of quickly. So we are doing 800 times the scale factor of 64/729. And you let your calculator do the work. 800 times 64 divided by 729, unless you're large and you want to do it by hand. Just kidding. And then you press math, enter, enter. And it's a really ugly answer that really doesn't have very good real-world applications. So this is a problem where in the directions on a test, I would tell you to round it. I don't want your answer as a fraction because it doesn't really make sense, okay? So I'm getting, I hope you're getting the same thing, about 70.2 cubic meters. Yes, units are important. Yes, I want you to put your units. What questions can I answer about this problem? Okay, yummy Twix. If 2 candy bars have a scale factor of 2 to 7 and the surface area of the mini candy bar is 56 centimeters squared, find the surface area of the king size candy bar. So we are assuming that these are proportional, even though the king size has 2 in it and the mini size has 1, but just pretend that they're totally proportional, okay? The scale factor is 2/7, so that's going from the large to the small, right? The surface area of the mini candy bar is 56 centimeters squared. Okay, so this is the mini one. The mini one is 56. Now, I'm not going to multiply that by 2/7 because that one goes from big to small. 2/7 goes from big to small. I don't want to do that. I want to go from small to big. So my scale factor is 7/2. But my problem is that this is surface area. This is 2D and my scale factor is 1D. So I need to do something to my scale factor. What am I going to do to my scale factor? Square it. Very good. So I'm going to square my scale factor, and now I'm allowed to multiply. You don't have to square it and then multiply. You can just put all of that in your calculator at once. 56 times, parentheses open, 7 divided by 2, raised to the third, or to the squared, sorry, raised to the second power. Hopefully you get that the surface area is 686 squared centimeters. Square centimeters. Okay, now, some of you might have a question mark over your head and might say, I don't get what you did. Why did you flip the fraction over? Then you squared it. I'm confused. You could always set up a proportion instead. You don't have to use scale factor. So you could say 2 is to 7 as 56 is to x, because this is the small candy bar and the small candy bar. 2 is to 7 as 56 is to x. You could say, oh, this ratio is 2D. This ratio is 1D. I need to do something about that, so you could go ahead and square that ratio. If you would rather do it as a proportion, that is perfectly fine. Moving on. Lars says that's a lot more work. Two similar cones have volumes of 216 and 512. If the radius of the smaller cone is 9, what's the radius of the larger? Volume. How many dimensions is volume? 3D, right? I would mark it. 3D, 3D. I would mark how many dimensions all of my information is. Radius. How many dimensions is a radius? Trace ledges. 1D. It's just a segment. A radius is a segment. So this is 1D. So we already know we're going to have to do some work. What do I want my answer to be in? I want my answer to be in 1D. So instead of raising 9 to the third power, what am I going to do to 216 and 512? Do you know what the opposite of cubing something is? Cubic root. Cube root. Yes, cube root. I am going to do proportion for this one because they didn't give me a scale factor per se. So I'm going to do a proportion. The volume is 216 to 512. Sorry, that was weird. 216 to 512, and that's a 3D figure. Okay, the radius of the smaller one is 9. So I'm going to put 9 with the smaller one, and then x. Okay? 216 is to 512 as 9 is to x. One of those columns is 3D, one is 1D. You cannot cross multiply. So we are going to take the cube root, and we're going to take the cube root. Now, where is that one in your calculator, you might ask? Everyone go to math, and then look at number 4. Math 4. So the cube root of 216 is 6. The cube root of 512 is 8. So we're doing 6 is to 8 as 9 is to x. Now we can cross multiply because this is 1D and this is 1D. So we are allowed, green light, you're allowed to cross multiply. X is 12 centimeters. The radius of the larger cone is 12 centimeters. Yay! That got easy so quick. Okay, good. Okay. Oh, we're done. Woohoo!